Okay, today we're going to talk about the power of a power rule and a power of a product rule for the laws of exponents. And these two are very closely related. One is what happens when we're just looking at one base and it's being put to, that has a power and it's being put to another power. And the other one is where we're looking at an expression, which has typically a coefficient and a variable, or could have a coefficient and multiple variables. So let's start in our math interactive notebook. Go to our paper one. And in our TOC, we need to enter power of a power and power of a product. And we're starting on page 8, and we'll see how many pages we need to do both the laws and the examples. So going to page 8. Power of a power rule. So a power of a power rule occurs when an expression with one number or variable is put to another power. Now, how we represent that symbolically would be if we have a to the m to the n, so that's written as a to the m to the n. What do we do in that case? Basically, we already know that m is telling us how many times to multiply a by itself. N would be how many times we're asked to multiply a to the m by itself. So the way we represent that is m times n. So just like when we had this, we looked at it as repeated multiplication, right? And this is also repeated multiplication of multiplication. So that's why we have our powers being multiplied. So some examples of that would be if we had 2 to the third power to the second. So this is telling us that this exists twice. So that would be like having 2 to the third times 2 to the third. And if we wrote that in expanded form, it would be 2 times 2 times 2 to represent that expression. And then we'd have 2 times 2 times 2 to represent that expression. So if we counted it out, we'd wind up with 2 to the 6th power. In other words, 2 to the 3 times 2 equals 2 to the 6th power. And of course, if I wanted to put that in standard form, I would just multiply 2 by itself 6 times. So some other examples. M to the 4th to the 3rd. So m to the 4th 3 times. And I'm not going to write that out in expanded form because I already know in the product law that we've already studied that if I have the same base with exponents multiplied, I could add them. So 4 plus 4 plus 4. So that would be 8 plus 4 more would be 12. In other words, m to the 4 times 3 would give us m to the 12th. And let's do a fraction. We have 1/3 squared, and then we're squaring the whole thing. This is telling us that inside it's squared. So if I follow the order of operations and I work inside out, I'd have 1/3 times 1/3, or I can write that as 1 to the second and 2 times the second. And this is being put to the second. So this is where kind of distributive property comes in when you have those parentheses. This 2, just like this 2, needed to apply to both the numerator and the denominator. So I'd have 1 to the 2 times 2 on top, and I'd have 3 to the 2 times 2 on bottom. So 1 to the 4th over 3 to the 4th. And of course, we always know 1 to any power is just 1. So I could leave it like that, or I can actually find out 3 times 3 is 9, and I have that twice, so that would equal 1 over 81. And that is power of a product rule, or power of a power rule. Now let's look at power of a product rule. So this is when we have an expression with more than one number or variable being put to another power. Okay, so the way we'd represent that symbolically would be A, B, and we can say these are both to the m to the n. So I'd have A to the m times n and B to the m times n. So some examples to that, if we just kind of build off of what we had up here, if we took 2n cubed and we squared it. Well, first go through each part and make sure you know what the exponent is. So when I look at 2, 2 doesn't have an exponent here, so it must be 1. And n has 3. So this would be 2 to the 1 times 2 and n to the 3 times 2, giving me 2 squared times n to the 6th. And 2 times 2 is 4, so 4n to the 6th. And that would be my final answer. 4m to the 4th cubed. So I don't see an exponent with 4, so it's just a 1. So 4 to the 1 times 3 and m to the 4 times 3. So I'd have 4 cubed and m to the 12th. 4 cubed is what? 4, 16, 40, 24, 64. So 64 m to the 12th. Now what if I had a cubed b squared to the 4th? So this 4 has to apply to both of them. So a to the 3 times 4 and b to the 2 times 4. Give me a to the 12th, b to the 8th. And again, let's do a fraction. What if we had 1/3 p squared squared? So one thing I need to know, if I have a variable sitting next to a fraction like that, I could actually put it in the fraction. It would go on top. So I could rewrite that as p squared over 3. And that's being squared. So on top I'd have p to the 2 times 2. On the bottom I'd have 3 to the 1 times 2. So I don't see an exponent there, so it must be 1. So p to the 4th over 3 squared will give me p to the 4th. P to the 4th over 9. Okay, so those are how you do power to a power and power of a product. And we can see that this really is just the same exact thing. We just have an expression that has more than one, number, typically a number and a variable in it, or could have 2 variables, or could have a fraction in a variable. It has more than one item going on. So we have to make sure that we distribute that exterior exponent to each base inside of the parenthesis. Now what you want to do is proceed to your digital notebook and do the GP pages that are in there regarding power of a power and power of a product.